We'll now look at integrals called improper integrals. And there are two types of improper integrals, but in this video we're going to deal with the first type, infinite intervals. Improper integrals on infinite intervals look like this. These are integrals that run from a to infinity or from negative infinity to b. In addition, it could be a combination of these and actually run from negative infinity to positive infinity. The main thing is one of our limits of integration should be either infinite or negative infinity. So how do we actually evaluate these? The first one, the ones that go from a to infinity, we're just going to take the limit as b goes to infinity of the integral from a to b of f of x. So we'll integrate the exact same way we normally did, but when we evaluate, we're just going to take the limit as b goes to infinity. The next one, the ones that go from negative infinity to b, we behave similarly. This time we're going to take the limit as a goes to negative infinity of the integral from a to b. So let's look at some examples to see how this works. My first example, the integral from 2 to infinity of 1 over the square root of x dx. Our rules say we want to take the limit as b goes to infinity of the integral from 2 to b, and I'm going to go ahead and rewrite this as x to the minus 1/2. So I still have the limit as b goes to infinity. When we're integrating, we add 1 to the exponent and divide by that number. Dividing by 1/2 is the same thing as multiplying by 2, and we need to take this between 2 and b. So now I have the limit as b goes to infinity of 2 times b to the 1/2 minus 2 times 2 to the 1/2. This number here, the second one, is just 2 root 2. And the first one, well, we need to take the limit as b goes to infinity. The square root of a really big number is still a really big number. So the limit of this thing is actually infinite. So this integral is infinite. This time, I have 1 from negative infinity to 0 of 1 over 1 plus x squared dx. We now need to take the limit as a goes to negative infinity. The integral from a to 0 of 1 over 1 plus x squared dx. So we have the limit as a goes to negative infinity of, well, if you remember your derivatives, this integral gives us arctan. The derivative of arctan is 1 over 1 plus x squared between a and 0. So now I have arctan of 0 minus the limit as a goes to negative infinity of arctan of a. Arctan of 0 is 0, and as we go to negative infinity, arctan approaches negative pi over 2, so the final answer here is going to be pi over 2. We'll now do the so now I have the limit as b goes to infinity of negative cosine b minus negative cosine of 0. And this limit here we know doesn't exist. So this integral diverges. So it is possible for these integrals to diverge as well.